Okay, we're live now.
Awesome. We're on week 8, right?
Yes.
Lesson 14.
This is so much faster than my computer. Alrighty here. So in an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate at least one mean is different than the others. Is that true or false? What do you guys think? ANOVA. Whoa. Whoa. Let me see here. Who's all here in the studio? We have Danielle, Andrea, Allie. So we're really only missing Ricky, and she's the one that emailed us, right?
Yeah.
Mm-hmm.
Okay.
Let's see here.
Well,
I'm pretty sure it's true.
I think it's true.
I don't see why it would change unless ANOVA is opposite, which I don't think that is the case, but... Anyways, I'm going to just double check that really fast, but let's go ahead and put true.
Okay.
And look at it really fast. So, what requirements need to be checked when performing an ANOVA hypothesis check or hypothesis test? Sample means are all positive. Data in each group are normally distributed. Variances are equal in each group. I think really just the middle one and maybe the first one.
Let's see here.
Because really in any data sample, it needs to be normally distributed.
Yeah, that seems about right.
Yeah, because in the textbook it says the data are normally distributed in each group, and the variances are equal for each group. So it would be the last one too, right? Because it says requirements, and then under it says data are normally distributed in each group, and the variances are equal for each group.
An ANOVA test, literally, like, all that's trying to say is that all the means are equal, is the null hypothesis. And the alternative hypothesis is that one or more of the means are different from the others.
So would it be the third one too?
So number 3 is false because that's the alternative hypothesis. Wait.
You mean number 5?
Oh, sorry. No, number 3 is true because there is sufficient evidence to indicate that at least one mean is different from the others. Yeah, sorry. Number 3 is right. Number 4, then data is normally distributed and the variances are equal for each group. So number
2 and 3.
Yeah, 2 and 3.
So 4, it's not the first one; it's the last 2.
Yeah, the last 2.
Okay.
It's the only one that we don't mark is sample means are all positive. That one is not true. To check if each group is normally distributed, do the following. We check it by creating a QQ plot for each group
I
separately.
think it's the third one.
Yep, it is that one.
The QQ plot?
For each group. Number 6, we assume the variance in each group is the same if the following happens. If the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal. What does that mean? If the largest variance is less than or equal to 4 times the smallest variance. So it's, I think, the second one.
Yeah, it's the second one.
Okay. An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs: 1, 2, 1, 3, 2, 3. That's interesting.
Wait, sorry. For 6, it was the second one?
Yes, correct. So for number 7, I always get confused with this kind of stuff. How many pairs would there be if there was 4 samples? Is that, it's 4, right? I don't know how to, like, that one. I always get confused when counting that kind of stuff.
Are we talking about question number 7?
Mm-hmm. Well. Because if there's 3 samples and it's 1, 2, 1 and 3, and then samples 2 and 3. If there are 4 samples, then it'd be 1 and 2, 1 and 3, 2 and 3. But then
And 2
you
and
don't
4.
account for 4. So really you'd have 1 and 4, 2 and 4, and 3 and 4 as well. So it'd be 6, I think.
On number
7?
That sounds right.
There's 2 sample t-tests between every pair of samples. So whatever that means. What do you guys think?
This question.
Has anybody taken a look at the data yet for soccer shoes?
Yes, I was just looking at it right now.
So there's 5 types of shoes, and I think we have to do a 2 sample t-test study between each pair. Like, that's a lot of work. Ugh. Google Spreadsheets is the same thing as Excel, right?
Yeah.
I think so. Wait. Did anyone ever find the answer for question number 7?
This one's a problem. That's so funny. If you wait, what? Oh, that doesn't make any sense. So wait, there's 5 types of shoes: A, B, C, and D. A, B, C, D, and E, and also just wearing socks for a total of 6 groups. Never mind. So each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. What is the minimum smallest variance for the 6 groups? Round to 3 decimal places. Crap.
We're still on 7, aren't we?
Yeah.
Okay.
Well, no, we're on 8. Sorry, I think 7 was or was question. I think it was 6.
Okay. That's what I thought. I just wasn't sure. I've been looking at the soccer shoes.
Well, yeah, this one's just going to take a lot of work, so I think we should probably split it up between us. Because we're going to have to probably create, like, let's just say it's, oh, I'm not sure what it would be.
I don't know that we have. We should be able to do this on the Excel spreadsheet.
No, that's what we're going to be doing it on. It's going to be a lot of work is all. Started on it. So, how about we split it? There's 4 of us, right? Is Andrea there?
Yes, I'm here.
Does everybody have their Excel spreadsheets up?
Yeah.
with the quantitative inference one as well.
I don't have a quantitative inference.
What are we doing? A 2 sample t-test? Is that?
I believe that's what it said.
Okay.
Well, maybe it didn't say it there. Let's see where it said it. Oh, never mind. This shouldn't be too much.
That's what I was.
Do the one-way analysis of variance, and then. Okay, I didn't see that tab there.
It's okay. I just saw it too. I was just about to say it.
So we do the ANOVA one, and then we just put in each variable. Okay, this shouldn't be too bad.
Cool. So we can just you can copy and paste it in there.
That's what I'm saying.
Okay. I have so many tabs.
I was afraid that we're gonna have to do like sample 2 t-tests for like each one.
Yeah, it's the ANOVA tab, isn't it?
Something like that. Yeah, it's the ANOVA tab. You're right.
Making sure I was on the right one. I have like 6 tabs open. No joke.
Let me know when y'all are finished.
Oh, well, it's taking a minute.
I'm only on C. Man, that would suck to have to kick a ball with your socks. I don't know about you guys, but we always played with hard soccer balls. Never those like nice soft ones that people typically buy. Okay, well, I mean, I have it all in there, and it looks like it's well done, I guess. Are you all seeing this?
So I got. Have you gotten the answer yet?
Well, it depends. So what is the minimum smallest variance for the 6 groups?
I'm seeing.
It's looking to be 32.
Or
no, sorry, 29.45.
I have 27.208.
You say 27?
Yeah. No.
The smallest, which one are you looking at? You're looking at the means, or are you looking at, variance? You're right.
Yeah. It's a
Sorry,
small
my bad. 27.208?
Yeah.
Okay, yeah. I think that's it.
And then for the largest, it's 53.158. If we're looking at the variance.
3.158. I think you're right about that one. The test for equal variances is satisfied for these data. I do not know. Let us check. So, So if the largest variance is at least 4 times as big as the smallest variance, we will conclude that the population variances are not equal. Well, I'm confused at what it means by the test for equal variances is satisfied for these data. That's weird wording right there.
I think it's true because I think it's just saying like, does it even out like in the end?
I don't know. I was thinking it was like kind of like reject or fail to reject the null hypothesis, but I guess that's different. Um, well, what do you think is the largest? Is it at least 4 times the size of the lowest one?
You're on 11, yeah? Or are you still on 10?
I'm still on 10. Sorry.
Okay.
The variance. So the biggest one is 53, and the smallest one is 27, and that's definitely not 4 times as big as. So I think we can assume that it's pretty much equal, is what it's trying to say. Does that make sense? If the largest variance is not 4 times as big as the smallest variance, we will conclude that the population variances are close enough that we can assume that the variances are all equal. And I'm not sure what to do with that, so I guess we can put down true. I'm not really sure what that exactly entails. So 11, construct a QQ plot for each of the 6 samples. Each of the samples are approximately based on what you see in the QQ plots. Oh, so we have to click true if we've done it. So what's a QQ plot again? That's the... Is that the 5-number summary or...
Yeah, I think so, yeah. Yes.
Weird.
Looking at the thing.
What are you looking at to try to figure out the QQ plot? Where are you looking at?
Well, I think we have to construct it. Like, it's not asking anything specific. It's just asking if we did it or not. So, I don't know. I was thinking I was just going to do that right now. But I can't remember. The QQ plot is, no, the box plot's a graph. The QQ plot is, what was that? Oh, the QQ plot's the line that goes down the middle. And okay.
Yeah, and then you can tell if the data it goes straight down the line or not.
Yep. How do we make a QQ plot?
I think there's a way to do it in Excel.
Oh yeah. I think do you go to like insert or something like that?
You go to insert,
Graph.
and then up at the top, there's all these little graph options, and then you find the QQ plot option.
Okay. QQ plot would be like a scatter plot? No.
Should be more like let's see.
It's not a column. It's not a histogram. It's not a box function whisker.
I think it's gonna be.
I feel like it'd be a line or like a...
I think it's true.
Oh, for that one? Yeah, it's true if we've done the work, yeah. We can just click true, but we have to do the work, so we'll go ahead and move on, and each of you can go ahead and construct your own Q plots later. If you perform an ANOVA test, you'll observe that the p-value is 0.081. Remove the SOX data and perform the text again, or the whatever that was. So we take out variance 6, right?
Yeah. I got 0.309.
For the
For 12, sorry.
0.309?
Yeah.
Yeah, I got that too.
Mm-hmm.
The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left of the F statistic? I think it's to the right.
Right.
What did you guys get for 12? I somehow missed that one.
You have to take out all the data for the SOX data, and then you have to look at
Okay.
what the p-values change to.
Wait, for number 12, so what was your name? What did you get?
Well, we got
0.309.
0.309.
Okay.
Anyways, yeah, it's definitely right skewed for question 13. Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is available in the file DSAL Hot Dog Nutrition. Let's examine calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs, then compare the variances to determine if the assumptions to use the ANOVA have. Just give me a second. Ooh.
You guys get 13 on 14 now?
I'm not sure where we're at.
Because 13 is
You know,
13, it's right.
Mm-hmm.
And 14 A.
Well, I wasn't able to get a QQ plot, but I was able to get like a waterfall chart. Man, I need to figure out how to do that. It's actually kind of making me mad. wish that we had I mean, that seemed pretty important, don't you think? Maybe it's like a 3D map or something.
Yeah, you'd think.
Illustration, maybe? It's not a table either. Anyways, yeah, I'm not really sure how to do. I'm gonna look it up really fast. How to do a QQ plot. Select an empty cell to store the histogram table. Locate the descriptive statistics icon in the toolbar. Click the down arrow, or here, actually, I'll do the YouTube video. It's from Excel 2003. That's a long time ago. Oh, that's cool. You can arrange your data to like ascending or whatever. Like trying to figure.
I have here a data set of 100 students. So I have student one, all the way one normally distributed. And if you notice across the top, I have their labels: ID, height, weight, age. I can sort by any one of those labels. So what I'm going to do is I'm going to click this drop-down box, and I'm going to sort my data by gender to separate. So I'm going to sort by gender. Click OK. You see now the men and women are mixed in. You have male and female mixed in. Once I click OK, it separates it out in alphabetical order. So the females are all on the top of the data set. And then when you get to, and it's going to ask me, I'm going to sort from A to Z, sort from Z to A, or do I want to do a custom sort? I'm going to select 7 because the first row is the, so the second tab has only the females. What I'm going to do is I'm going to go ahead and see if the weights of these women come from a normally distributed population by creating a normal quantile plot. So, first things first, I'm going to go ahead and I'm actually going to resort the data now and females' weights in order. In order, we have female weights in order now. Let us go ahead now and create a counting variable. So I'm going to create a counting variable to count up and see how many weights there are. We said there were 57. Let's make sure. So I'm going to call my counting variable I, and I'm just going to let I count all the way from 1 to whatever the number of females were in my samples. The next thing I'm going to be up to 57. So now I have one column that represents counting from 1 to the last data value. The next thing I'm going to do is I'm going to try to divide up this space, the 0.5 here. So I'm going to click enter. Oops. Theoretical values are going to go. I like this, and I'm going to find the inverse normal from standard normal probability. If I have 57
Man,
now let's do the average.
this sucks.
And a bunch of functions start. Your theoretical Z. It's for
Man,
theoretical Z and the actual Z.
I have no idea what this thing's saying.
Insert.
It looks like we have to like do a lot more stuff just to be able to find the QQ plot, like the Z-score and all that stuff. Is that already provided in there, or?
It should be. I'm trying to find it right now.
But it's like supposed to be like the Z-score for each individual one.
Yeah, but we should be able to do it in the
Well, I would think so, but
Nova thing. Like there should be a thing for Q plots, unless it's in a different Excel spreadsheet that
it's not in a different Excel.
shouldn't be.
But yeah, to do a QQ plot, you actually, it looks like it's not like an actual chart. You actually do put in like equal and then whatever it is that it was.
And go over to the chart wizards here. And the chart that I want here, XY scatters.
Oh, it's an XY scatter plot that we want.
Hold on one second. My boss is calling me. I don't know why.
Okay. Well, it's the XY scatter plot, so we already have it. So let's go ahead and try and do that then. So highlight all the variable 1 or whatever. Go down and then pick the scatter plot. I mean, it doesn't look right, but at the same time, it does.
Guys, I have to go because I was scheduled for work at 10:30, and that's weird because I shouldn't be scheduled then. So I have to go into work.
That's fine.
But I'll have to finish the quiz on my own later. Yeah. But I'll go ahead and submit what we have for the meeting.
Oh, okay.
Just let her know that I had to leave.
Sorry about that.
It's okay. I'll see you guys on Wednesday.
All right. Bye.
See you later.
Yeah.